Hello and welcome to Aviation 101 with Laura. We are continuing the series about the simulated oral for the aircraft dispatcher practical exam. This time I am looking at task D, which has called weather-related hazards. I have that pulled up on the PTS, which I will link to in the video description so you can follow along. This one I'm going to give you like questions and then my suggested answer so you can practice. And there's the other version I'm going to release. Could be that one you're watching where I'm just giving questions. You get to fill in the blank your own answers. However, this one's going to be a little bit better for you to actually like use my scenario because of how this task is structured. Other thing I want to say, I did turn on my channel membership opportunity if you want to support the channel and the work I'm doing and like basically kick it up a notch. You get some cool bonus features, especially our members only every fourth Monday live stream. And there's the details in that. I will put a link in the description for how you can join as a supporting member. Okay, so this task is weather-related hazards. And let's just look at what the practical test standard says. It says that the examiner needs to see if the applicant has adequate knowledge of weather hazards, the elements of weather hazards, by applying all performance penalties and corrections on the manual flight plan dispatch release and appropriately briefing or discussing with the examiner weather hazards such as. Then we have a big list. So for this part of this task, I'm actually going to look at the idea that they're saying applies, basically looking at this relating to a manual flight plan dispatch release. Okay, but I'll release another one where I'm going to just ask general questions about these hazards, and it won't necessarily have to do with any specific flight plan. So this is the first time I've really shown you guys what a flight plan at my dispatch school class looks like. This is what it looks like. This is just the fourth exercise that the class does. And there are some various things that we have to pay attention to with related to weather. So I'm going to be kind of switching back and forth with the practical test standards here, but you can see that it says like you need to apply performance penalties, corrections on the manual flight plan. So that can mean like not routing the aircraft through areas of thunderstorms. That would mean that you need to be able to identify, how am I going to know where there are thunderstorms? Well, clearly we're going to get to that. But it can also be knowing your aircraft's limit, like crosswinds and gusts. Like for example, if you have, actually it doesn't say crosswind, but tailwind limitation on your aircraft, you should not be planning the aircraft to arrive on a runway that exceeds the tailwind component. Or planning to arrive with lower than your required visibility, or planning a takeoff when you don't have the required visibility to have that flight be dispatched. So, all right, without further ado, we're going to kind of look at this flight plan. I'm going to be like the examiner, and I'm going to ask some questions having to do with this flight plan and like that list of weather hazards. Okay, so this flight plan is going from Seattle to San Francisco. There's a little map. Okay, great. The basic information is on the front here. Any MELs are listed out, and we may be talking about those, or you can check out my video about MELs, CDLs, okay? But then here is all the information, and I'll zoom in, on our weather. So since this is related to weather-related hazards, we will get started with this. So, okay. And just so we're clear, the flight is supposedly going from Seattle to San Francisco, but there's a lot of weather information given from multiple airports, because when I'm making this flight plan for my students, I want them to figure out what should be my alternate. Do I need an alternate? And then pick from the suggested options of alternates. Okay, so I'll pretend to be the examiner. Okay, so with this flight plan you have today, are there any kind of concerning weather issues that you want to bring to my attention if you're giving me like a weather briefing for this flight, or anything that was impacting your ability to dispatch the flight, or what you were looking at for weather hazards? Okay, yes. So for this flight, since we are going from Seattle and we're going down to San Francisco. Here's my weather for that. One thing I noticed right off the bat is that in this METAR for Seattle, the visibility is quite low. It's currently in the METAR at 1/4 statute mile, and on runway 16 right, the RVR is 1,600. And so there's not much wind going on. The clouds are broken at 100-foot ceiling, so there is a low ceiling going on. My main concern is this really low visibility and whether or not I can dispatch the flight. Then I continue looking at this and looked at this TAF, which the first line, it doesn't look too bad, but we have this tempo between 1800 and 2000 on the 27th, where the visibility is forecast to be a 1/4 mile visibility. And so again, that is a really low visibility that I noticed. So what can cause this kind of low visibility that you're seeing here in Seattle? Well, okay, Seattle's on the coast. There is a lot of moisture. It's actually America's only rainforest. It's not a tropical rainforest, but it is a rainforest, temperate type of area. It's on the coast. We have mountains involved. So we often get like a fog area. This METAR for some reason doesn't say anything about fog. I think that's probably what's causing this. It doesn't say it. I also noticed that the temperature and the dew point are exactly the same, 6 degrees. If I look at this temperature dew point reading, the temperature is 6.1, the dew point is 5.9. So the spread is very close, hence our visibility restrictions that are going on. And yeah, so that's most likely what's happening there. Okay, what about the weather in San Francisco? What other weather hazards do you have in this flight plan you were looking at? Okay, so yeah, in San Francisco, again, we're talking about a coastal area. I did notice there is a 1 statute mile visibility in haze and fog, few clouds at 100 feet. That's our METAR. I mean, 1 mile visibility is low, but it's not impossible for us to operate with a 1 mile visibility. I'm definitely looking at that as a pilot and a dispatcher. Then in this TAF, we've got a tempo line from the 27th from 1800 to 2000, 1 statute mile visibility and fog. It looks like, so that's actually happening just like this METAR is saying, it's following the tempo. But it is a 4-hour period, so I would be looking at, unfortunately, I just have 1 METAR. I would prefer to be looking at trends on these METARs, see what's going on with the weather and where this might be headed. Like, has it been worse and now it got better, or is it on its way getting worse? Again, we have the same temperature and dew point here in San Francisco. The spread, when you look at the 1/10 of a degree, is a little bigger than we had in Seattle, but it's still really close. Okay, what about en route weather? Okay, good. So our en route weather, if I'm looking at, like, I have a bunch of air mits here, and actually I can show you where I plotted them on my really old school flight plotting chart. But here is where we're going. We're going from Seattle. We're going down here to the San Francisco area. Okay. And so I did plot this. There are some thunderstorm areas that are to the south. So we're going to get to that. There is some area of turbulence. So we'll get to that. With these air mets, these ones are all having to do with turbulence, and they are moderate turbulence. They all say moderate turbulence there, and I know what's why air met gets issued if it's turbulence air met. So I'm not super concerned with this. I would maybe mention it to the captain so the captain can brief the crew to make sure the flight attendants are seated, especially if they're flying in any of these areas. But let's keep going down here. We have a couple air mets for icing. Honestly, with a 737, like I'm dispatching here, moderate ice to flight level 180 from the freezing level to 180. This airplane can handle ice. It is excellent. Later we'll talk about systems and I can explain our anti-ice systems, but I'm not really concerned about icing for this type of aircraft, this operation. So here are the SIGMETs I was mentioning. We have a couple convective SIGMETs that are going on. And like, for example, this one, northwest of Las Vegas to northwest of Coaldale. So I've actually plotted that here. So here's Las Vegas and here's Coaldale. And you'll notice that's nowhere near our flight route. We're going to Seattle to San Francisco, so I'm not worried about this. Okay, I do have this other one that is kind of to the south of where we are. So that would be right here, this convective SIGMET it's valid until 2055, California, Arizona, these are the states that it affects. And there's a line of thunderstorms 20 miles wide. It is moving from 300 at 10 knots, and the top's going up to flight level 450. And there's isolated embedded thunderstorms, 20-mile diameter, moving from 260 at 20 knots, tops to flight level 350. So there's that going on. That is actually what I've plotted, like right there. I don't know about my line of the movement. That seems a little weird. But then, yeah, this occasional severe turbulence, that's really the one that gives me the most concern because of its location and what is going on. We have this one here. Yes, 60 miles northeast of Oakland. So that's near San Francisco, to 40 northeast of SNS. And I have to look on my chart there. There's SNS. Okay, so we do have the area around San Francisco. And what does it actually say? So it's a SIGMET. It's not a convective SIGMET. A SIGMET saying, yeah. So the SIGMET says that we have this area, occasional severe turbulence below 4,000 feet due to low-level northeasterly flow across mountainous terrain, reported by several small light aircraft, conditions ending by 2135. Zulu is what they expect. Okay, so why is turbulence a hazard for us in our big Boeing 737? Well, okay, so turbulence is hazardous for us because, well, severe turbulence means that we're going to be very dangerous if people are moving around the cabin. If we let passengers go to the lavatories or the flight attendants are walking around the cabin, they could get injured because severe turbulence, if you look at the definition in AIM, it is where like walking is difficult and dangerous. And the fact is that aircraft can unexpectedly hit pockets of air where that air, basically wind changing direction, wind flow changing direction or changing speed. And this SIGMET right here says it's because we have the northeasterly flow, they're talking about wind, flowing across mountainous terrain. So we have a flow of air hitting some terrain. It's going to get turbulent as it goes over the terrain. And so those eddies create bumps. People could get hurt while moving around the cabin. The aircraft could get damaged. And so that is why that is a hazard for us, even in a big aircraft. Okay, you also mentioned this thing about the convective SIGMETs. Why are thunderstorms a hazard to us in a Boeing 737? Okay, well, thunderstorms are hazardous to us. There are many hazards in thunderstorms. Thunderstorms imply potentially hail, which obviously is bad for denting aircraft, breaking windshields, getting ingested into engines, and damaging many things about the aircraft. Hail is very bad. Even strong amounts of precipitation, like heavy dropping precipitation, if an aircraft flies through that, it can, even a large aircraft like turbojet, turbofan engines, if you ingest lots of water in the engines, you do run the possibility of having those engines flame out, which is clearly bad. But these two things have brought down aircraft in the past. So, but not only that, with a thunderstorm, we have the risk of lightning discharge. It can hit the aircraft. This is not necessarily, aircraft are designed to withstand lightning strikes, but lightning hitting the aircraft, not something we want to happen. It can mess with the avionics. It certainly is gonna do something to the aircraft as far as people will notice. It's not bad, it's not good. The other super bad killer in convective activity and thunderstorms is people getting hurt from and airplanes getting destroyed or damaged from severe turbulence. So I know that the convective sigma doesn't say any of these things, but all of these things are implied by thunderstorms. So we really do not want to fly in thunderstorms because the amount of turbulence with the amount of movement of air in a thunderstorm can significantly damage or destroy an aircraft. And also we have a potential, there's a lot of liquid supercooled water in a thunderstorm, potentially. If an aircraft flies through that, it can collect heavy severe icing can form on the aircraft, could even be enough to overwhelm the anti-ice systems that we have on board the aircraft. So passengers also do not like flying in thunderstorms or even super near thunderstorms. So all these are bad things about convective sigmets. Okay, let's look back at our PTS and see what else is going on. Okay, so you mentioned that we have poor visibility. How would we know if we had a contaminated runway? What is that about? Okay, so a contaminated runway is one that's not dry, basically. So for this specific flight, if I take a look at like leaving from Seattle, I don't actually see anything in here about precipitation. We're going down to San Francisco, and once again, I don't see anything in here about precipitation. If the runway were contaminated, we would have a field condition report that would be given to us in the NOTAMs. And I have a few NOTAMs, but the NOTAMs I have for Seattle have to do with an approach light system not working and a runway that's closed for construction. And in San Francisco, it's an approach light system, again, that's not working. So there's nothing on there about field condition reports. So I didn't have any reason to expect a contaminated runway for this operation. Okay, so talk me through how you planned this flight specifically. Is there anything that you did relating to the surface visibility restriction? So what I did differently or to enhance safety with our visibility restriction and to make sure the flight was legal, I did this form, which is one of the forms we use at LeTourneau University, where I am evaluating a runway for departure at Seattle. I chose runway 16 center, and I made sure that with the current visibility that I do have the required visibility to depart. And so this form actually helps me apply the Jeppesen takeoff minimums page. If you don't know what I'm talking about, look at the video description. I'll put something in there with that video. But here, I need to first make sure that I can take off using off-spec C78 lower than standard takeoff minimums. But 14 CFR also requires me to, as a dispatcher, identify if the airport where we're leaving from, in this case Seattle, has such low visibility, in this case it does, that I could not do an instrument approach back to our departure, so that's Seattle. Then I have to choose a departure alternate, sometimes called a takeoff alternate. So in this case, at our departure time, the METAR said that the quarter-mile visibility was what was going on. So that does let me depart, but I cannot come back to land at Seattle with an ILS because the ILS that our company can fly only goes down to half-mile visibility. So if it's a quarter-mile visibility, I can't fly the ILS. Now, the reason 14 CFR says we need to choose a takeoff alternate or a departure alternate is so that if something went wrong on departure and we need to get the aircraft on the ground quickly, I have pre-identified for the captain a departure alternate that's legal where we can go land that's somewhat close to the departure airport. And it needs to, for the 737, for our manual, it needs to be within 250 miles. That's defined as, for 14 CFR, 1 hour flying time with 1 engine inoperative in still air. So we're gonna assume that's a 250 mile radius. For this departure, I went ahead and chose Portland. Portland is pretty close to Seattle. I'll show you that in a second, but it's pretty close. And so I used the various approaches that were available, and I actually derived alternate minimums for Portland of that we need a 500-foot ceiling and 1.5 statute mile visibility if we were to have to divert to Portland as my departure alternate. You also said there's low visibility in San Francisco. So did you have to do anything for that for enhancing safety? Yes. So in San Francisco, yes, the visibility was only 1 mile, and that was what we saw in the forecast. So, and it was also going on in the METAR, I believe. So for that, again, for safety reasons and for regulatory reasons, I have to add an alternate airport. And in this case, my alternate airport, I decided to use San Jose. So it's not too far away, but the visibility there was excellent. It's actually farther from the bay, so it had better weather. I had no problem, and I chose to do a alternate airport for San Jose. Okay, so where did that show up in your flight planning, and how would the captain know this? Okay, so the captain would know this in a couple different ways. First of all, this is my weight and balance form, and it's also my runway limiting weights. So if you look at this box here, you can see that I have found a limiting weight that includes going to an alternate. So there's that. I've also picked a takeoff alternate and figured out the limiting weight for runway 28 left if I were to go land at Portland. So that's one way. And then let me show you the other way. So right here, I have a dispatch release that is for leaving Seattle. Then Portland is my takeoff or departure alternate. San Francisco is my destination, and San Jose is my alternate airport. So under 14 CFR, when I'm preparing this dispatch release for the captain, which then I sign, I have to list on there all the airports, and I have to make sure that the weather is okay for them to be used at their different arrival times. So there's that. And then also what I've done is on this flight plan, I have basically identified an alternate of San Jose, and I figured out how many minutes and how much fuel to go there. And I made sure that I put enough fuel to go to the alternate. And this is also actually visible here to the captain. So I have my burn to get from Seattle to San Francisco, my 45-minute reserve, some alternate fuel. This could be contingency fuel, but this fuel needs to be on board the aircraft, as well as, of course, if I have enough fuel to go all the way from Seattle to San Francisco, I definitely have enough fuel to go to Portland, because I basically would be landing before I get to San Francisco. And so that would be illegal. And that's how the crew would know. Okay, how would you know if there was a volcanic eruption that might impact the flight? Okay, yeah, so I don't know, Mount Rainier blew up. Hope not, because my brother lives there. But yeah, so if there were a volcanic eruption, that would actually be issued as a SIGMET. It wouldn't be a convective SIGMET, but it would cause a SIGMET to be issued, and it would be listed on my briefing package. I don't have any SIGMET for a volcanic ash event happening, so I'm assuming Mount Rainier is still good, not erupting. But the other place, you could look at the Volcanic Ash Advisory Service. I don't have that, but if it were actively erupting, we would be having a SIGMET issued, and it would be listed here as what was going on. Okay, good. So we're going to stop there. And next time, we're going to take it up with more questions, because obviously I cannot make a flight plan for everybody that has a hurricane and a typhoon and a tornado and a thunderstorm and a microburst and all these things going on, and turbulence and wind shear and all this stuff. But we will get back to more questions with that with part 2 when we continue with task D about weather-related hazards. Thanks for watching Aviation 101 with Laura. Have a great day.